All right, so let's talk about 4.1, all about the polynomial division and the factor theorem. So let's get to it. We can divide polynomials by using long division just like we do with numbers, and let's remind ourselves how that works with numbers, right? So if we want to divide 3,235 divided by 6, then we put 6 on the outside of the little box, and then we do 3,235 on the inside, and then we ask ourselves, does 6 go into 3? And the answer is no. So then we ask, does 6 go into 32? And the answer is yes, right? It goes in 5 times. Then we multiply, subtract, and bring down the next digit. Then we rinse and repeat until we're out of digits, right? So 3 times, and bring down the 5, and then 9 times, and we have 1 left over. So this number right here is called the quotient, right? So we call 539 the quotient, and this number down here we call the remainder. So 1 is the remainder. So another way to think about this is that 3,235 is really 6 times 539 plus 1. Okay, it's divisor times quotient plus remainder. That's how we that's how we can rewrite the dividend. Okay, polynomial division works the same way. When we're doing polynomial division, there are just a couple things to keep in mind. First of all, it's easiest if we keep the polynomials in descending order. Okay, and then also it's easiest if we make sure to write out the missing terms. And by missing terms, I mean if you're looking at something like x cubed plus 5x squared minus 3x plus 1, there are no missing terms there, right? The exponents go 3, 2, 1, 0. But something like x to the 6th plus 3x to the 4th plus x minus 1, this does have missing terms. It has missing terms. It's missing an x to the 5th, it's missing an x cubed, and it's missing an x squared. So instead of writing x to the 6th plus 3x to the 4th plus x minus 1, when we're doing long division, we would write out x to the 6th plus 0x to the 5th plus 3x to the 4th plus 0x cubed plus 0x squared plus x minus 1. Let's get to it. Let's do a couple examples. Okay. So I want to do x squared minus x plus 1, right? Rewriting it in descending order, into x to the 5th plus 0x to the 4th plus 4x cubed plus 2x squared plus 0x plus 7. Okay, so that's how we would write this out on part A. And now to do the division, we start off by asking ourselves, well, how many times does x squared minus x plus 1 go into x to the 5th? Which is kind of a weird way to ask the question. A better thing to do would be to say, well, forget these other terms. Just think about x squared. How many times does x squared go into x to the 5th? Or better yet, you could ask, what times x squared equals x to the 5th? And the answer is x cubed, right? X cubed times x squared is x to the 5th. X cubed times negative x is negative x to the 4th. And x cubed times 1 is x cubed. Now we subtract. And the x to the 5ths are gone. This is going to become a positive x to the 4th. And then this is going to be 3x cubed. But then after we subtract, don't forget we've got to bring down the next digit. In this case, the digits are terms, so we're going to bring down the next term. And then we repeat the process, right? We ask ourselves, what times x squared equals x to the 4th? And the answer is x squared, right? X squared times x squared is x to the 4th. X squared times negative x is negative x cubed. And x squared times 1 is x squared. Then we subtract. The x to the 4ths are gone. 3x cubed minus negative x cubed is a positive 4x cubed. 2x squared minus x squared is a positive x squared. Bring down the next term. x squared times what equals 4x cubed? And the answer is 4x, right? 4x times x squared is 4x cubed. 4x times negative x is negative 4x squared. 4x times 1 is 4x, and then we subtract. We've got 5x squared minus 4x plus 7. And one more time now we ask ourselves, what times x squared equals 5x squared? And the answer is 5. And then we multiply this out. 5 times x squared, 5 times negative x, 5 times 1, and subtract. Then we're left with a positive x and a positive 2. Okay? So that's how long division works with polynomials. So we would say the quotient is x cubed plus x squared plus 4x plus 5, and the remainder is x plus 2. Okay? Let's do another one. Let's do part B. So we've got x cubed minus 1 divided by x minus 1. So again, we're going to do x minus 1 on the outside, x cubed plus 0x squared plus 0x minus 1 on the inside. And then we ask, what times x is x cubed? And the answer is x squared. Then we subtract. Right? And now we ask, what times x is x squared? And the answer is x. X times x. X times negative 1, subtract. And then we ask, what times x is x? And the answer is 1. Multiply that out, and we get 0 this time. So this time we don't even have a remainder. In other words, x minus 1 goes into x cubed minus 1 evenly, and what's left is x squared plus x plus 1. That actually should have been pretty obvious to you if you think about factoring. If you think about this as a difference of cubes, and the factorization of a difference of cubes is, well, in this case, it's going to be x minus 1 times x squared plus x plus 1, right? That's the factorization. Okay, so that's how long division works with polynomials. Now, speaking of what I just said about factorizations, right? A polynomial d is a factor of another polynomial f if you can rewrite f as d times something else, right? With no remainder left over. Okay. So from example 1b, we can see that x minus 1 is a factor of x cubed minus 1, right? But from example 1a, we see that x squared minus x plus 1 is not a factor of this big polynomial that we started with, right? Because when we did that division, we got a quotient, but we had a remainder left over. So in other words, it's not possible to rewrite this polynomial as this times something else, right? You can rewrite it as this times something else plus a remainder, but you can't just write it as this times something else. And so consequently, this is not a factor of our original polynomial. Okay, so factors are polynomials that go into other polynomials with no remainders left over. Now, suppose that we want to solve something like p of x equals x cubed minus 1, and that, suppose that we want to solve this equation, right? P of x equals 0. So we want to solve x cubed minus 1 equals 0. We would begin by factoring, right? X cubed minus 1 is x minus 1 times x squared plus x plus 1. And then we set each factor equal to 0 and solve. By setting x minus 1 equal to 0, we get the solution x equals 1. By setting x squared plus x plus 1 equal to 0, we would get two more solutions. I don't really care about those for the time being. Okay, but what I want to point out is that it should be the case that p of 1 equals 0. And in fact, you can verify that, right? If you plug in 1 to p of x, right, 1 cubed minus 1 is 0. Okay, so p of 1 equals 0. So to summarize, if x minus 1 is a factor of p of x, then p of 1 equals 0. In general, we can say this. F of x has x minus a as a factor if and only if f of a is 0. Okay, so if this is a factor, x minus a is a factor, then the number a makes f of x equal to 0, right? I was about to say this. I was about to say, so let f of x be a polynomial and let a be some complex number. If f of a equals 0, then a is called a 0 of f. So what I was about to say here is that x minus a is a factor if and only if a is a 0, right? And that's what I mean. So in other words, 1 is a 0 of the polynomial p of x equals x cubed minus 1. Now, if your head is swimming right now, if you're like, what in the world is he talking about? It's because I keep saying the same thing over and over and over again. And it's really not difficult, okay? It's as easy as you think it is. So don't overthink this. But what I'm trying to say is this. The following statements are equivalent. Saying that a is a 0 of f of x is the same thing as saying that a is a solution to the equation f of x equals 0. And that is the same thing as saying that x minus a is a factor of f of x. They all mean the same thing. Okay? So let me show you how the factor theorem can be applied. So is x minus 2 a factor of x to the fourth minus 3x cubed plus 2x squared minus 3? Well, there are a couple ways that you could figure that out. One thing that you could do is you could divide this polynomial by this polynomial, and if you get a remainder of 0, then yes, this polynomial would be a factor of that one. But another way to do the same thing, that's going to be a lot quicker, is to notice that if x minus 2 is indeed a factor of this polynomial, then when you plug in 2 to this polynomial, you're going to get 0. Okay, that's what we're saying up here. So that's a much quicker thing to do. I'm just going to call this polynomial, I'm going to call it p of x. And what I want to do now is look at what is p of 2. If p of 2 is equal to 0, then x minus 2 is a factor, for sure. All right, so let's see, p of 2. 2 to the fourth minus 3 times 2 cubed plus 2 times 2 squared minus 3. That's 16 minus 8 times 3 is 24 plus 4 times 2 is 8 minus 3. 16 minus 24 is negative 8. Negative 8 plus 8 is 0. 0 minus 3 is negative 3. So is x minus 2 a factor of this polynomial? No, right? Right? It's not a factor of p of x. Okay, let's look at another one. Is x plus 1 a factor of this nasty thing? Okay, same idea. If x minus 1, or sorry, if x plus 1 is a factor of this, then negative 1 should be a 0 of this polynomial. So let's see if it is. Again, I'm going to call this polynomial, let's call it f of x. So I want to look at f of negative 1, right? Be sure to change the sign. Negative 2 changes to positive 2, positive 1 changes to negative 1. But I want to see if f of negative 1 is 0. Let's see. Let's see, this is going to be just 2 minus 9 plus 10 minus 12 plus 12 plus 45. I don't think so, right? It doesn't seem like it. Did I get all this right? 2, 9, 10, 12, 12, and 45. Yeah, 2 minus 9 plus 10 minus 12 plus 12 plus 45 is 48. So x plus 1 is not a factor of f of x. This makes me think that I must have made a mistake on number 2, because it doesn't seem like me to give you two examples where they're both not factors. So did I do something wrong here? 2 to the 4th is 16. 2 cubed is 8, and 8 times 3 is 24. 2 squared is 4. 4 times 2 is 8, and then minus 3. 2 to the 4th, 3 times 2 cubed, 2 times 2 squared, minus 3. Okay. 16 minus 24 is negative 8. Negative 8 plus 8 is 0. Yeah. Well, there you go. I don't know. I'm getting no in both places. Okay. Moving on. Given that f of x equals 2x cubed minus 9x squared plus 4x plus 15, and that f of 3 equals 0, solve f of x equals 0. Okay, well, so I'm given this kind of weird clue right here. I think I'm just going to ignore that for now and see if I can just solve the equation, right? I want to solve f of x equals 0, so I want to solve 2x cubed minus 9x squared plus 4x plus 15 equals 0. Now, since this is a 4-term polynomial, the only tool I have in my toolkit is to factor by grouping. So if I group the first two terms together, I can take out an x squared, and I'm left with 2x minus 9. If I group the second two terms together, I can't really factor out anything. I'm left with 4x plus 15. And now I have a problem because these two things don't match. So I'm stuck. That must be why they gave us this extra clue right here, right? They're telling us that f of 3 equals 0. What does that mean? Well, f of 3 equals 0 means that x minus 3 is a factor of f of x. Now, what does that mean? Well, that means that when I divide f of x by x minus 3, I'm not going to have any remainders. So if I want to factor f of x, well, then I can use the fact that x minus 3 is a factor and see what I have left over, right? So let's do that. Let's factor f of x, or let's divide f of x by x minus 3 to see what I get left over. So I'm going to do x minus 3 into 2x cubed minus 9x squared plus 4x plus 15. Okay, x times what is 2x cubed? I think it would have to be 2x squared. We subtract, we get negative 3x squared. X times what is negative 3x squared? I think it would have to be negative 3x. So we get negative 3x squared plus 9x. We subtract and we get negative 5x. X times what is negative 5x? I think it would have to be negative 5. Negative 5 times x. Negative 5 times negative 3. And sure enough, we get a remainder of 0. So what this tells us is that f of x is equal to x minus 3 times 2x squared minus 3x minus 5. Okay, very good. Now, can I factor this trinomial that's left over any further? Let's see. If I can, it must be 2x and x, and it must be 5 and 1, but where should they go? If I put the 5 here, I'm going to get a 10. That's probably too much, so I think maybe like this. And I think I need this to be negative and this to be positive so that I get 2x minus 5x, and that'll give me a negative 3x. So there you go. There's the factorization. I want to solve this I want to set this equal to 0 and then solve. So what this tells me is that x minus 3 is 0, or 2x minus 5 is 0, or x plus 1 is 0. That means x is 3, or x is 5 halves, right? Add the 5, divide by 2, 5 halves, or x is negative 1. So there you go. 3, 5 halves, negative 1. Okay. Very good. So that's how that works. Let's look at another one. Number 5 says, given that 2 plus I and 2 minus I are zeros of this thing, find the remaining zeros. Well, this is a 5-term polynomial. I don't have any techniques for factoring 5-term polynomials. So if I want to find, I'm given 2 of the zeros, but if I want to find the rest, I've got to factor this thing, and I don't know how to factor it. Well, here's what I'm going to do. I'm going to use the fact that 2 plus I and 2 minus I are zeros, right? What does that mean? That means that x minus 2 plus I and x minus 2 minus I are both factors of f. If these are both factors of f, then their product is a factor of f. So I'm going to multiply these two things out to see what I get. If I multiply these out, I get x squared. Right? I get x squared. Then I get negative 2 minus I times x. Then I get a negative 2 plus I times x. And then I get this nasty business. The negative and the negative make it positive, but it's going to be 2 plus I times 2 minus I. So now I've got some more work to do. I'm going to run out of space, so I'm going to pull this over here and maybe do a couple steps on the same line. But I've got an x squared. I'm going to have a negative 2x and a negative 2x. Those are going to combine to give me a negative 4x. I'm going to have a negative, or sorry, when I distribute this negative sign, this is going to become a positive I. So I'm going to do a positive ix and then a negative ix. So those will cancel, right? The imaginary parts are going to cancel there. That's good. And then for this, I'm going to have 4 minus 2i plus 2i cancel, minus I squared. A negative I squared. Remember that I squared is negative 1. So negative I squared is positive 1. And 1 plus 4 is 5. So this should be x squared minus 4x plus 5. Wow. That's just the first step in the process. Okay. But I know now that this polynomial is a factor of f, which means when I divide f by this polynomial, I should get a polynomial back out with no remainders. So let's do the division. X squared minus 4x plus 5 into x to the fourth minus 3x cubed minus 5x squared plus 29x minus 30. Now, what times x squared equals x to the fourth? The answer is x squared. I'm going to multiply. And subtract. Oh, I better check my work. Negative 4x cubed, 5x squared. Okay, it just seemed a little fishy. Like it almost seemed like these should have canceled, but they don't, right? Negative 5x squared minus 5x squared. So I think we're good. What times x squared is x cubed? I think the answer is x. X cubed minus 4x squared plus 5x. I'm going to get negative 6x squared plus 24x. Bring down the negative 30. And then I think x squared times negative 6 would give me a negative 6x squared. So multiply this out, a positive 24 and a negative 30. Wouldn't you know it, right? You get remainder 0. Okay, so what does this tell us? This tells us now that f of x equals x squared minus 4x plus 5 times x squared plus x minus 6. And now if I want to solve that for 0, well then I would try to factor further, right? I already know that this polynomial gives me solutions 2 plus I and 2 minus I, right? This polynomial came from these two zeros. So I'm not going to bother factoring that one any further, but I do want to try to do x squared plus x minus 6. So this is going to be x squared minus 4x plus 5 times x plus 3 times x minus 2, I think does the trick. So the remaining zeros are negative 3 and positive 2. And there you go, right? So the zeros are, well, the 2 we were originally given, 2 plus I, 2 minus I, but then also negative 3 and positive 2, right? So those are the zeros. Okay, so you can see, polynomial division and the factor theorem and all of that stuff, it's good stuff. It's good information. It helps us to do a lot of good work with polynomials. Let me give you one more example. This one says, if negative 2, 3, and 7 are zeros of a polynomial, f of x, and f of x has degree 3 and leading coefficient 1, find f of x. Well, if negative 2 is a 0, then x plus 2 is a factor. If 3 is a 0, then x minus 3 is a factor. And if 7 is a 0, then x minus 7 is a factor. Moreover, if these three factors are all factors of f, then their product is a factor of f. Now, here's something else. We know that f has degree 3. Well, guess what? When you multiply these three factors out, you're going to get an x cubed somewhere, right? So this is a degree 3 polynomial. That means there are no other factors here, okay? These are the only three factors that we have to deal with. We also have coefficient 1. Well, leading coefficient 1, right? So when you multiply this out, your x cubed term is going to be a 1x cubed. So that's good. That tells us this is the polynomial in question, right? And we could multiply this out, right? We get x squared minus 3x plus 2x minus 6. And then we can FOIL that out further. We would get x cubed minus 7x squared minus x squared plus 7x minus 6x plus 42. That's x cubed minus 8x squared plus x plus 42. Okay, and there you go. So that's how you do that. All right, so at this point you should be pretty convinced that solving polynomial equations and performing polynomial division go hand in hand. In particular, we end up doing a lot of division by factors of the form x minus a, right? By little linear factors like this, x minus a. And this will become even more clear to us in the next section, right? In the next section, we talk about the rational zeros theorem, or the rational roots theorem, depending on who you're talking to. But the rational zeros theorem basically gives us a way to find the zeros of a polynomial one at a time. And then to find the remaining zeros, we end up dividing the original polynomial by the factor that we found the first time around. And so we end up doing a lot of division by factors of the form x minus a. So I'm going to introduce a shorthand way to do this, and it's called synthetic division. Okay, So let me show you how synthetic division works. So let's do this division. First we'll do it using long division, and then I'll show you how it works using synthetic division. And I think you'll be convinced that, at least for for factors like this, synthetic division is really the way to go. So let's do this. We want to do x minus 1 into x to the fourth minus 3x cubed plus 0x squared, don't forget your missing terms, plus 7x minus 5. What times x gives us x to the fourth? The answer is x cubed. Multiply this out. You get x to the fourth minus x cubed. Subtract. And you get a negative 2x cubed left over. Bring down the 0x squared. I'm going to stop talking. That way you can hear my girls singing in the background. They're always making up songs. I don't know if you can even hear them, but they're quite entertaining. Okay, so there you go. That's how that would work with long division, right? So we've seen this multiple times now. But here's how this would work with synthetic division. So with synthetic division, you use the 0, not the factor. In other words, x minus 1 is the factor, but that corresponds to a 0 of positive 1, right? So I put a little positive 1 in the box, in a little box like this. And then I just write out the coefficients, right? So I write out the coefficients, 1, negative 3, 0, because I'm missing a 0x squared, 7, and negative 5, okay? Different people have different ways of showing their work here, but what I like to do now is skip a line and then just put a horizontal line here. And now here's what you do with synthetic division. This first number gets dropped straight down. Then you multiply this number times that number and write the answer here. 1 times 1 is 1. Then you add these two things, and then you multiply and put the answer there. Then you add these two things, and you multiply and put the answer there. Then you add these two things, then you multiply and put the answer there. Then you add these two things, and you're done. This last number is the remainder. In this case, we have a remainder 0, which corresponds nicely with what we got when we did long division. The rest of the digits are the coefficients on the answer, right? Starting with, your constant term, and then your x term, and then your x squared term, and then your x cubed term. So the answer should be x cubed minus 2x squared minus 2x plus 5. Just like we got before. But I think you'll agree, this is a lot less work, right? It's much nicer. So synthetic division is really a nice tool for doing division like this. Now the caveat here is that you can't use synthetic division for doing like degree 2 division. So if you wanted to do a division problem kind of like this one that we did in example 5, you wouldn't be able to use synthetic division for that. Okay, you can only use it when you have these nice linear terms. But as we'll see, there's going to be lots of times that we're going to want to do these kinds of divisions, and so synthetic division comes in nicely for those. Let me just give you a little bit more practice with synthetic division. Okay. So I'll walk you through another one, and then I'll let you try out part B on your own. So it says, use synthetic division to perform the following division. Let f of x equal x to the 6th minus 5x to the 4th, blah, blah, blah. Calculate f of x divided by x minus 2. Okay. So the 0 is 2. The coefficients are 1x to the 6th, 0x to the 5th, negative 5x to the 4th, 0x cubed, negative 29x squared, 0x, and 105. And now, we drop this first number down, then we multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply. Oh, goodness. 132, is that right? Maybe 132. I better make sure. 66 times 2. I'm no good at math. Yeah, 132. And then add. Okay. And that's that, right? That's all there is to it. So f of x is well, maybe I should say this. So maybe I'll say it like this. F of x divided by x minus 2 is, well, let's see. This is x to the 0, x to the first, second, third, fourth, fifth. So it's 1x to the fifth plus 2x to the fourth minus x cubed minus 2x squared minus 33x minus 66. And then this is a remainder. So what do we do with the remainder? Well, we write it as a fraction. We say, so it's minus 27 over x minus 2. Okay? Okay, so there's the answer. I'm going to let you work out part B. So go ahead and give the video a pause and see if you can work it out on your own. Here's my solution without talking. First of all, make sure that the 0 is negative 3, right? If the factor is x plus 3, then the 0 is negative 3. Oh, this one comes out nice. You get a remainder of 0. So you get x cubed minus 6x squared plus 13x minus 10. And that's it. Okay, so there's synthetic division. Let me give you one last example. It says, given that negative 2 is a 0 of this polynomial, solve f of x equals 0. Okay, well, if negative 2 is a 0, then that means x plus 3 is a factor. But since negative 2 is the, or sorry, not x plus 3. If negative 2 is a 0, then x plus 2 is a factor. But I'm going to want to divide x plus 2, or I'm going to want to divide f of x by x plus 2. And the easiest way to do that is to just use synthetic division. So, and with synthetic division, I use the 0, not the factor. So I'm going to use the negative 2, actually. And then I have 3x cubed, negative x squared, negative x, or negative 20x, and negative 12. Okay. Let's do this. We should get a remainder of 0 if we do this right, because we know that negative 2 is a 0. Wouldn't you know it? It's beautiful. Beautiful when a plan comes together. Okay, so now f of x is, well, it's x plus 2 times 3x squared minus 7x minus 6. And we want to solve f of x equals 0. So I'm going to set this equal to 0 and solve now. Ooh, can we factor this thing? 49 is 4 times 12 6. I don't think we can. Maybe we can. x and x. 2, 3. Maybe we can. Let me try. So, oh yes, like that, right? But where do the signs go? It should be -9 and a +2 to give us a -7. Okay, well that wasn't terrible. There you go. So, so the zeros, -2, -2/3, right? Subtract the 2, divide by 3, so -2/3, and then +3. Okay, and that's it. I think I've already given you this warning, right? Synthetic division only works for factors of the form x minus a or x plus a. For something like this, we would have to use long division. Okay. Do I have any more in this section? No, that's it. Okay, so that does it for that one. That's 4.1. So I'll see you in 4.2.